Hello learners, welcome to CS Teaching Exam Prep. Today in this video lecture we are going to discuss all the possible MCQs on the concept memory, memory devices, storage format and also the units of memory. So in the syllabus mentioned, we are going to discuss these concepts: memory, primary memory, cache memory and secondary memory, and also the basic units of memory. Coming to the first question. A computer system usually stores a block of data or information in the form of. So computer system, what it is asking is how it will be storing the data, in which form. Yes, stores a block of data. So if we consider like data in the memory will be stored in the form of bits. Yes, so the address of that particular memory cell is also being accessed by using bits. Okay, so how can we access this? So whenever particular memory device is present based on the size of the memory, so it will be divided into some set of memory cells. Yes, it will be divided, the block of that particular memory will be divided into memory cells. Each cell has its unique address. Each cell has its unique address. Each cell of the block of memory has its unique address. That address will be in the form of like zeros and ones. Yes, representation, the address representation is in the form of zeros and ones. So now the question is asking is usually stores a block of data or information in the form of. So if we combine these bits, we can form a byte. Okay, group of bits, we can say a byte. Like group of bytes of data, we can consider it as a word. Okay, so what does this block of information is? What does this block stores is? It is in the form of computer words. Yes, so group of bytes, it will be combining group of words based on the size of that particular memory device. It will be divided into number of cells. Okay, so if the size of that particular memory device is 2 GB, let us consider. And so what is the range of values accessed by 2 GB memory? That is like 2 into 2 power 30 number of memory cells. It can divide, this memory device can divide the number of memory cells ranging from 0 to, yes, 0 to 2 into 2 power 30. That is like 2 power 31 we can say. 2 power 31 is, that is some large number of cells we can divide. Okay, so based on the range of acceptable values or range of acceptable unique addresses, so the data will be stored in each memory cell. So how it will be stored, it is not like a single bit or a single byte, but the data will be stored in the form of like group of bytes. So when we consider group of bytes, they will be it will be termed as the computer words. Okay, a 4-bit word is called a 4-bit word. Like single bit, we can say 0 and 1s, that is like bits. Like a group of 4-bit word, if you have 4 bits 0 1 0 1, it is considered as a nibble. A 4-bit word is called a nibble. And if we consider an 8-bit 0 1 0 1 0 1, let us consider 0 0, so 8 bits, group of 8 bits, we can form it as a byte. Okay, so a 4-bit word can be called as a nibble. Okay, 2 nibble word, from this we can understand 8-bit word is called as a byte. Next question. The CPU interacts directly with the dash to perform read or write operations. Yes, so whenever we want to process something, whenever we want to access something from the computer, so obviously the data will be stored in memory devices. The data will be stored in memory devices. So whenever, as we are saying, CPU is like will be performing all the processing. Yes, central processing unit. CPU has to perform all the processing and CPU has to do all the read and write operations for the user whenever the user want to access some data or block of data from the computer. So where all this block of data or information is stored, that is stored in memory. Okay, so what does the CPU does? CPU will directly interact with which memory device, that is CPU will directly interact with this primary memory device. CPU will directly interact with primary memory. That what is this primary memory? RAM. CPU doesn't directly interact with the secondary memory because of speed compatibility issues. Because see, like secondary memory, everything data will be stored in secondary memory, that is permanently. Yes, permanent storage device we can say. But primary memory, it stores the data temporarily. Whatever the CPU wants to access from the memory devices, that data will be taken by this primary memory. It will take the data from secondary memory. It will access the primary memory, that is RAM, will access the data from secondary memory. Okay, temporarily it will store this data temporarily until the CPU needs that particular data to perform processing. Okay, so after CPU has done its processing, like processing means like either the read or write operations. After CPU finishes this task of read or write operations, again it will send back the results to the primary memory, and whatever the change operations or read or write operations, whatever the changes happen, and then from the RAM, by use of RAM, that data will be stored in secondary memory. Yes, so that is the purpose of this RAM. So whatever the like RAM size is limited, like 4 GB or some is limited, but not the size of the RAM is not equal to the size of the secondary memory devices. Yes, so as the size of the RAM is small, it can access only what is required by CPU. It will perform, it will give that particular data to CPU. CPU will perform all the changes or whatever the read-write operations has to be done and hand over the data to RAM. So from the question, the CPU interacts directly with it interacts directly with primary memory to perform its read or write operations. Next question. Now let us learn about RAM. What is not correct about RAM? In the question it is mentioning what is not correct. In the examination also you have to check if the questions are in the form of statements. So they will be mostly asking like not current, which is not true. Yes, or which is true. Yes, you have to check that. Read the particular question clearly. Okay, so which is not correct about RAM? So what is RAM? It is used to store data temporarily while the computer is working. Yes, RAM doesn't store the data permanently. RAM doesn't store. When the computer is turned off, it will lose all the data. Why it doesn't store the data permanently? That is of its limited size. It can be accessed only due to its high speed. When compared to the secondary memory. Okay, so what is this high speed? It can give the data to the CPU whenever it is required with almost speed. To cope up with the speed of the CPU, the RAM will be accessed in between the secondary memory and CPU. Okay, as the data will be permanently stored in CPU has to get the data from secondary memory device, but in between the CPU has its own speed of access time and secondary memory has its own speed of access time. But secondary memory access time is very larger access time. It can be accessed with larger access time, but CPU has to perform its task within like milliseconds or nanoseconds. Yes, so it has to improve its performance. CPU has to improve its performance. So that is why there will be RAM in the middle, so which operates or which cope up with the performance of the CPU, which gives the data or frequently used data or frequently asked data from the secondary memory to the CPU. So that is why it will be storing the data temporarily, as it is of smaller size than when compared to the secondary memory. And also that is why it is called as volatile memory. It is RAM is called as like primary memory and also main memory and also volatile. Yes, primary volatile memory. Next, RAM is usually this option is correct. RAM will be storing the data temporarily. Second option, RAM is usually referred to as main memory. Yes, so RAM is considered as main memory, where also we have secondary memory and main memory. So RAM is considered as main memory device. So this is correct. It is faster than the secondary memory or storage devices. Yes, obviously, other storage devices, when compared to other storage devices or external storage devices, RAM is faster. It can have the faster access speed than when compared to other storage devices. RAM is non-volatile. No, it is non-volatile. It is volatile. As we have discussed now, it is volatile in nature. That is, it will be losing its data once the power is turned off or once the task is done or once the computer is turned off. Okay, whenever we restart the computer again, the RAM will load particular another set of data required by the user. So what does it load? Like when we restart the computer again, initially before shut down the computer, we have performed some task. The user has performed some task. After shut down the computer and again restarting the computer, immediately what will be loaded into RAM? Whatever the boot program from the ROM will be storing the boot program that we'll be discussing in the next questions with the next questions. So all the boot program will be loaded into RAM, and RAM will be making the computer to get startup, to restart the computer. So immediately after the bootloader has loaded into the computer, the operating system starts its work. Okay, it has to check for the resources, it has to check for the hardware resources which are connected to the computer, and what are all connected, they have to become, all the devices has to become active. Okay, so this is all about RAM. Next we'll be discussing about ROM, or in the coming lectures we'll be discussing about the lecture videos about the operating system concepts also. Okay, now coming to the next question. Coming to the next question, which of the following is not correct about ROM? ROM is non-volatile, means its contents are not lost even when the power is turned off. What is volatile? When the power is turned off, when the computer is turned off, it will remove the data, it will lost its data. Non-volatile is it will retain the data even when the power is turned off. What is the ROM contains? It contains the startup program. The startup program, when we restart the computer, it loads the operating system content into RAM, is stored in a ROM. Obviously, whenever we restart the computer, the boot program has to be loaded such that first it loads irrespective of other software applications or whatever the remaining hardware drivers to get started up before the operating system has to be loaded into the computer system. So after operating system is loaded, then it will find out the interface between the applications whatever the user is opening and the hardware devices required to open that particular application. So that is why operating system is called as the interface. It acts as an interface between the hardware and software. So whatever the startup program immediately after restarting the computer is loaded, that is stored in ROM. It never loses the data, it always stores the data even when the computer is turned off. So that is why it is called non-volatile memory. It is faster permanent storage for the contents which are rarely changed. Yes, it is type of the permanent storage. It stores permanently data, so such that whenever we start up the computer, the data will be loaded into RAM. So whatever the data is loaded into RAM, it is stored in ROM. It is also known as secondary memory. ROM is not considered as secondary memory. RAM is considered as primary memory. Also ROM is considered as primary memory only. It is not considered as secondary memory, even though like based on the requirement, even though it is storing the data permanently, it is not considered as one of the secondary memory devices, but it is considered as only primary memory. It is considered as only primary memory. So which of the option is not correct? It is also known as secondary memory is not correct. Next, RAM is faster than secondary storage but not as faster as a computer processor. Yes, computer processor works very faster in order to have more performance in much less time. Okay, so RAM is faster than secondary storage obviously, but not as fast as computer processor. Next question. The average time required to access frequent data from primary memory can be reduced by using the average time required. So whatever the data we are accessing from the memory, it has to be required by the CPU. CPU needs the data in order to process something. From where it will access the data? It will access the data from primary memory. So how can we reduce the access time whenever the CPU is accessing the data from the primary memory? How can we reduce the access time? So how can we reduce? By using secondary memory between CPU and primary memory. By using secondary memory, do we have to use secondary memory between primary memory and CPU? No, secondary memory speed is or access time or the speed of accessing the data of secondary memory is very less compared to primary memory. So no need of having secondary memory in between CPU and primary memory. A very high speed memory is placed between the CPU and the primary memory. So till now we have discussed in order to cope up with the speed of the CPU, we need the primary memory, that is RAM, in between the CPU and the secondary memory. As the data is permanently stored in secondary memory, primary memory, that is RAM, will access the data from the secondary memory. So in order to have the average access time, in order to have the reduced average access time, so we can use very high speed memory device, that is cache memory. That is cache memory we can use. Okay, that is the second option saying. Now coming to the next option, more number of registers. If we want, do we have to use more number of registers? We can, but it is not the easy task. Like registers are very costly. Registers are very costly. After that, the costly is cache memory, and after that it is the primary memory is very costly compared to the secondary memory. So in order not to use more number of registers, the cost of the computer system will be increased. So we can use a cache memory in between CPU and primary memory. And also one option is registers. Registers are very small in size. They cannot accommodate very large data or information. Okay, so we can use cache memory in between the CPU and primary memory. Why? In order to reduce the average access time to access the frequent data. Next, which of the following cannot be directly accessed by CPU? So we can directly, the CPU can directly access primary memory. Yes. It can directly access cache memory. Yes. Can it directly access secondary memory? No. Secondary memory, CPU cannot access secondary memory directly. Either it has to interact or it has to try to access the data from cache memory first. If the data is not available in cache memory, then it will check or it will go through the primary memory. So whenever the data required by the CPU is available either in cache or primary memory, it will access that data, but directly CPU cannot access secondary memory due to the access time or performance or speed issues. Okay, which of the following is true about an solid state drive? Solid state drive, it is one of the external memory device. Solid state drive is Now previously we have discussed like internal and external storage device. It is one of the external memory or external storage devices. So what is this solid storage drive? See, which is true? The question, you have to check the questions also in the examination. Sometimes there will be a question like which is not true, which is true. You have to check that first and then go through the options. Whenever, and another small tip is like whenever you go through the options, so you have to select the elimination method. So okay, you have to compare with the question, the option no. So like that you have to eliminate maximum options and you have to select one correct option from the given options. Now coming to these options, the solid state drive, what is true? Support very fast data transfer speed as compared to earlier HDDs, that is hard disk drive. Hard disk drives are also the external memory devices. Second option, it is a semiconductor based device, uses flash memory to save persistent data. Flash memory, here we got the term flash memory. Portable USB flash drive is an example of SSD technology. Yes, this is an example of solid state drive. Solid state drive one of the best example is USB flash drive or USB memory sticks. Yes, so those are the examples of solid state drive. So which is true? So these options all are very true about the solid state drive. Come see the first option. So very fast data transfer speed as compared to hard disk drives. So we can transfer the data, like whenever we use USB ports or USB cables, we can transfer the data very fast when compared to hard disk drives. Yes, it is very true. It is semiconductor based device. It is the solid state drive is semiconductor based device, uses flash memory. So whenever it is using flash memory, obviously USB or external storage devices comes under this flash memory. Okay, next, which of the following has lowest access time in the computer memory hierarchy? So whenever we have memory devices, we are saying the CPU will access either cache memory or primary memory in order to process something, take the data from memory and process and return back the data. So while considering the access time, which has very lowest access time, which memory device has the very lowest access time? Which device? Secondary memory. Till now we have discussed cache memory can access the data within few milliseconds or nanoseconds to cope up with the CPU. Also RAM can also access the data, and CPU registers are directly attached to the CPU. Registers are directly attached to the CPU, small size, but these are of small size. It will be storing only very frequently used data. Okay, and after that cache, and after that RAM. The lowest access time considered first CPU registers will have the highest access time, and then cache, and then RAM. Just remember this. Coming to the next question, which of the following has a fastest speed in the computer memory hierarchy? Fastest speed. So in the memory hierarchy we can see the cache memory, registers in CPU, main memory. So we know the CPU will directly interact with the registers and then cache and then main memory. So which works with very speed access, that is the first registers. Registers are very small in size, very expensive, and has a very fastest speed access. Okay, next, in which type of memory once the program or data is written, it cannot be changed? So till now we have discussed about the RAM and how the CPU interacts with RAM. So in order to increase the average access time, in between we have to use cache memory, and also till now we have discussed about the importance of RAM and purpose of cache and registers in the CPU. So now let us go through ROM. Now, which type of memory once the program or data is written, it cannot be changed? ROM is also considered as one of the internal memory device. ROM is considered as internal memory device. So ROM is divided into, first, like we have MROM first, that is masked ROM. Okay, next we have PROM. We have PROM in the given order in the options: PROM, EPROM and EEPROM. Okay, MROM is like masked ROM, masked read-only memory. So whatever the instructions stored in the masked ROM, they cannot be changed, they cannot be accessed by the user. They are only developed, the programs whatever written in the MROM, they are developed by the manufacturer itself. Okay, so that is one type of ROM. And next we have PROM, programmable read-only memory, and EPROM, erasable programmable read-only memory, and this is electrically erasable. This is electrically erasable read-only memory, electrically. And erasable, here erasable, it is not electrically, just directly erasable programmable read-only memory. As the name suggests, erasable and programmable. Here also, as the name says, electrically erasable programmable read-only memory. Here only programmable. So what is the question asking here? Once the program or data is written, it cannot be changed. So in which type of memory? As the name itself saying, we cannot change, that is programmable read-only memory. It doesn't have like erasable. So whenever the user, here PROM can be changed by the user or the manufacturer. If the user or manufacturer once written or done with the program or data, it can be only written, but it cannot be erased or rewritten. Okay. Next, in which type of ROM data can be erased by UV light and then reprogrammed by the user or manufacturer? So here the question is saying erased and can be reprogrammed. So that can be done by EPROM, erasable programmable ROM. Okay, next question, that is EPROM. Which type of ROM is used for erasing only one byte at a time? So we have seen erasing cannot be done by PROM. It can do only program, writing the program, but it cannot rewrite the program or erase the instructions or the data from the ROM. Next, EPROM. So it can erase and program. It also can erase and program. Used for erasing only one byte at a time. So whenever we see this, EPROM can erase the complete content at a time, but EEPROM, electrically erasable programmable ROM, can do or erase only one byte at a time electrically. See here, EPROM, by passing some UV light or signals through the EPROM, we can erase the data and can rewrite the data. But this is electrically erasable, is done electrically, like these are some set of electronic devices, right? So it is erased electrically, and when it is doing erasing work, it will erase only one byte at a time, but not all the data or instructions at a time. So that is the feature of EEPROM, that is electrically erasable programmable ROM. Next question, what is the correct order of memory types from highest to lowest? Order of memory type, highest to lowest speed. So till now we have discussed about the lowest speed. Secondary, like highest. Secondary has the highest? No, secondary storage doesn't has the highest speed. So you can eliminate this option directly. Okay, CPU registers, we can go through these options. Cache memory. So when we have CPU registers, we can avoid this cache memory also. CPU registers have very high access time or can access the data with very high speed. Yes, CPU registers. After that we have first CPU registers, cache memory. Okay, Next, coming to this, after cache memory, in between we need to have main memory instead of having secondary storage. So we can eliminate this option also, main memory and then secondary storage. So the option C is correct regarding the highest to lowest speed access in the memory devices, that is CPU registers and then cache and then main memory and then secondary storage device. Coming to the next question, which of the following is not an computer internal memory? So we have discussed about internal, like types of computer memory. Those are divided into internal and external. Internal are very much attached to the motherboard. So cache, obviously it is attached to the motherboard. Optical, sequential access memory and virtual. Virtual memory is also like considered as internal memory. Why it is considered as internal memory and what is virtual memory? We shall see that in the next coming questions. Optical storage. Optical storage device is obviously coming under external storage devices. It is coming under external storage devices. External storage devices like optical, yes, optical and SSD, solid storage devices and magnetic devices. These all comes under, like magnetic storage devices, this all comes under external storage. Next, sequential access memory. Sequential access memory is using also internal memory. So we shall discuss about sequential access memory and what is virtual memory in the coming next questions. Okay, next, so optical memory is not a considered as computer's internal memory. Next question, basic units of memory are called obviously bits, like basic units, the minimum size of the memory, like starting from bits 0 1 0 1 0 1, yes, bits. After that we have nibble, after that we have byte, after that we have all the combination or group of bytes, we call it as word. As group of bits, we call it as byte, 1 byte, or bytes. Group of bytes called as words. Okay. Next, what is the minimum size of information needed to encode the characters of the text? So to encode, whenever encoding is happening, so encoding, we have this particular concept in our syllabus. We'll be discussing in the next coming video lectures very clearly. Okay, what is the minimum size of information? So to encode the data, like why we need this encoding? Whenever the user types something in the computer, so that particular data whichever the user is typing is in the form of high level, like English language, but the computer cannot understand the English language, as the memory devices are also storing the data in the form of machine language. Yes, the address of a particular memory cell, everything is being stored in the form of zeros and ones, that is machine understandable language. Yes, so whenever we type something through the keyboard, we input something through the keyboard to the computer system, then the data will be taken by the RAM and then the CPU will understand that, and the CPU needs to, like whatever the interpreters or the compilers or encoders which we are present in the computer, they change the data into the machine understandable language. Okay, so we shall discuss about this concept very clearly in the coming video lectures. Okay, so now what is the minimum size? So in order to encode the particular text or the characters entered by the user, the minimum size information is 8 bits. Yes, 8 bits. To particularly, it's like if you have a particular letter A, so A will be changed into the decimal format, and after that that decimal number will be, or the integer number will be taken, considered or changed into its ASCII code. It's ASCII code. ASCII code is like the one of the encoding format. Yes, so these all will be discussing in the next coming video lectures. Okay, 8 bits is the minimum information to encode particular characters or text. Next question. A megabyte, also termed as MP, MB, contains. So what are the units of memory we can see? So starting from the bit, we have bit, next byte. Byte is like 8 bits. Yes, byte is like 8 bits. Okay, and after that we have bits, bytes, and after that like we have 1 kilobytes, megabytes, gigabytes, terabytes. Okay, so 1 KB is like 2 power 10, 1 MB is like 2 power 20, 1 GB is 2 power 30, and so on. Okay, so 1 MB is, which of the following is correct? 1024 bytes. 1024 is 2 power 10. 2 power 10 bytes is obviously 1 KB. So this is not the option. Next, 2048. 2048 is like 2 power 11. 2 power 11 bytes? No, it is not. 1024 KB. 1024 KB is 1024 is 2 power 10 into again kilo, we have 2 power 10 bytes. Yes, so this will be considered as 2 power 20 bytes. So this is the correct option for this megabyte. So whenever we divide it in numeric terms, so megabyte is having the storage or 2 power 20 megabyte. Whenever the memory is told as MB, so it can store the data up to 2 power 20 bytes. 2 power 20 is very large number. Yes, 2 power 20 bytes of data can be stored in our computer's memory. Okay, next, match the following options. Yes, sequential access, random access, direct access, associate access. So what is sequential access? Like you'll be so from these options we can go through the elimination method. See, first sequential access, random access. Random access, like as the name says, we can directly attach this to random access, that is RAM and ROM uses the random access methods. Okay, random access methods. Next, direct access. So when can we use the direct access? Direct access method is used by hard disk. Yes, how it can use the direct access method? So whatever the data required by the CPU, immediately RAM can access that particular data, and it will directly access, the RAM will access the memory address of that particular data or information or instructions, and it can directly access. And so from the hard disk is using the direct access method to give that particular data to CPU. Associate access is done by cache, and sequential access is done by magnetic tape, one after the other. So magnetic tape will perform the uses the sequential access method. So after accessing, in order to process something, in order to access some data, so first memory cell will be accessed, second memory cell will be accessed, third memory cell will be accessed. Likewise, it will continuously access the data until it gets a required data. So random access, RAM will access the memory cells randomly. Yes, it will be considering any memory cell's address, or the address will be given by the CPU to access some data from main memory, from secondary memory. So direct access, yes, once the RAM gets the address or the particular memory cell's unique address from the CPU, it can, this hard disk can be directly accessed. So that is why hard disk can use the direct access method. Yes, associate access. So associate access is like whenever the CPU needs some information, it will directly give the information, or it will directly try to access the frequently used information from the cache. So that is why it has a direct access, associate access to the cache. So which option is correct? So the option B is correct with the following match. Okay, which type of memory acts as a buffer between CPU and RAM? between CPU and RAM. So we have discussed between CPU. So whenever the CPU needs the data, first it will check for cache. It will check for the frequently used data from the cache. If it doesn't get the data from cache, then it will go to RAM, that is main memory. So which is acting as a buffer between CPU and RAM? That is the cache memory is acting as a buffer between the CPU and RAM. In multi-core CPU systems, so nowadays we see multi-core CPUs, multi-core processors. Yes, all cores share which type of cache memory. So we have in memories we have levels of cache L1, L2, L3 as given in the options. So from these options we can learn one concept, that is levels of cache memory. Okay, so whenever the CPU needs some data, it will directly access the cache memory or first initially registers, as the registers are very small in size, but access speed or work speed is very faster. Yes, so level 1 cache, level 2 cache, level 3 cache and level 4 they are divided into. Okay, so in multi-core CPU systems, what happens is multi-core, let us consider we have like octa-core, we see the like quad-core. Yes, octa like 8, quad like 4. If let us consider we have 4 cores of CPU. Okay, 4 cores of CPU. Let us consider, just for an example I am telling you, 4 cores of CPU systems, that is like multi-core. So level 1 and level 2, each core of CPU will have its own level 1 and level 2. Okay, so how many cores the CPU or the processor may have? Level 1 and level 2 are different. Okay, level 1 cache is maintained by this core level 1 and level 2, and another level 1 and level 2 caches are maintained by this core. Okay, but which level is all cores sharing which type? That is, all cores will be sharing level 3. Okay, all cores will be sharing level 3 means, what does it mean? Each core of the CPU has its own registers and its own cache, but all the cores of CPU or the processor has main memory in common, that is main memory in common. Okay, L1 and L2, that mean registers or the cache are not shared. Each core has its own registers or caches, but main memory is common. How many number of cores we have in the CPU? This main memory is shared by all the cores of the processor. Next, level 3 or main memory cache will be shared to the all cores. Okay. Next question. Which type of memory is used to temporarily store the unused data of primary memory when it is full? See, what the question is asking is type of memory. Okay, temporarily store the data, the type of memory. Unused data of primary. So obviously primary memory will store the data temporarily, that is why it is called as volatile. Okay, when it is full. See, primary memory also has less size. See, size of the primary memory is very less than the secondary memory. Okay, so as the primary memory has to access the secondary memory in order to get the data required by the CPU will ask primary memory or cache memory to get the required data. So the primary memory has to interact with the secondary memory and it has to access the data. Let us consider the primary memory is like 4 GB RAM, let us consider. Okay, 4 GB. But the CPU is asking the data which is more than 4 GB. That is, let us consider the CPU is asking for 5 GB data. So what does the primary memory does next? What does the primary memory does? Now Let us see the options: cache, registers, virtual memory, secondary memory. So which type of memory? See, whenever the primary memory is accessing the data, so if the data, any kind of data which is not being used by primary memory for now, so that data will be stored into virtual memory. That data will be stored into virtual memory when the primary memory is full. Okay, so that is the option. So let us discuss about the virtual memory now. See, which is not the purpose of virtual memory. So virtual memory is like, it is part of the secondary memory. Okay, listen to this carefully. It is part of the secondary memory, but it is like it creates an illusion like it is a memory present in primary memory. Okay, it is a memory available in primary memory. How? Because whenever the primary memory is full, yes, the primary memory or main memory access is full, yes. So what does it do is, it will create an illusion like, okay, the primary memory is providing some space. No, but the secondary memory itself has the virtual memory space. So whatever the data is not being frequently used or unused data from the primary memory will be temporarily stored into virtual memory. Okay, temporarily stored into virtual memory, and after the primary memory performs its access to the CPU, okay, until then that data will be stored temporarily. It is part of the secondary memory. Virtual memory is part of secondary memory. Okay, but it creates an illusion like, okay, whatever the data present in primary memory, it is being stored in some part of primary memory itself, but it is part of the secondary memory. So what is not the purpose of virtual memory? It allows to add more physical memory by using a disk. Yes, I am telling you. So by using the secondary memory disk, it is creating an illusion like we have more physical memory. Yes. It allows to add memory protection. Yes, memory protection means like in order not to delete the data, from the primary memory. So it is saving or storing the same memory cells from the primary memory into virtual memory. It is changing that particular address, physical address to logical address, or logical address to physical address, but it is not removing any data from the secondary memory. So it is protecting the memory also. It frees up the space in primary memory. It frees up the space in secondary memory. No, it doesn't freeze up the space in secondary memory. It is freeing up the space in primary memory, because when the primary memory is full, it is creating an illusion like I can store the data from the primary memory until the primary memory takes another set of data. It performs its processing with the CPU, and then until it returns back, I am storing, virtual memory is storing the data temporarily. But it is not freeing up the space in secondary memory, but it creates an illusion it is present in secondary memory. Okay. Next. Which type of systems do not require secondary storage? Okay, secondary storage, like we know, like we can run the computer, we can use the computer system without storage also. Yes, but these internal memory devices like cache, RAM or ROM are very important. Yes, ROM contains the boot process or the basic information to restart the computer, to start the computer. Cache memory, after starting the computer, in order to perform very small tasks, it need to have the memory. That is like, what does this cache memory and primary memory stores? It stores the very frequent data, frequently used data. Okay, so whenever we are using frequently used data, only that much of memory might be enough. Cache memory or the main memory providing memory will be enough. There might be no need of any secondary storage like larger storage devices. So which type of systems may not require secondary storages? Washing machines, Washing machines may not require secondary storage. They doesn't require any. So washing machines, like the frequently used options, yes, obviously there will be using only some set of options. These options can be directly stored in ROM itself. Okay, read-only memory. ROM can directly store the instructions, frequently used instructions, permanently. Like whenever we use option like wash or rinse or drive, these are the frequently obviously used only options. Okay, so these instructions can be directly stored on ROM. Central heating systems like ovens will be having only some set of options, or even those options also can be directly stored in ROM. Okay, so that is why, like, they may not or doesn't require storage devices. So both A and B, washing machines or central heating kind of systems, they doesn't require any secondary storage. Which of the following is not a magnetic storage device? So under external, we have seen like magnetic storage device. Which is not a magnetic storage device? Hard disk drive, magnetic tape, floppy disk, USB flash drive. So hard disk drive is magnetic storage device. Magnetic tape, yes, obviously it uses the magnetic storage technology. Floppy disk, it uses them. So but USB flash drive, it uses SSD technology, solid state drive memory storage. Okay, solid storage drives these are. So USB flash drive is not one of the type of magnetic storage device. Next question, which of the following is not a solid state storage device? Solid state storage device, solid state drive, it is obviously a solid state storage device. USB flash drive, yes, USB related, those all comes under solid state storage devices. DVD ROM, it is not a solid state storage device, but it is an optical storage device. Yes, it is an optical storage device. Yes, DVD ROM. Next question, which of the following is a optical storage device? Yes, optical storage, CD ROM and DVD ROM are the two. So the option will be both A and C. These are the optical storage devices. So under external storage devices, we have seen what we have seen now, three types: magnetic, optical and solid storage. So under magnetic, magnetic tape. Okay, under optical, this CD ROM, okay, or DVD ROM. Yes, and under magnetic we also have hard disk drives. Okay, they all works under the magnetic storage technology. And here we have USB. Okay, solid storage devices, USB, CD ROM. Magnetic tapes, hard disk drive, this all comes under magnetic storage devices. And optical and these are SSDs. Okay, you have to remember these types, these are very important. Okay, yes, which of the following optical storage device? These are CD ROM and DVD, CD and DVD. Okay, now, okay, this is the end of this particular video session. Now this is the topic we have discussed under the memory. So in the next video lecture we'll be discussing about the types of software. Okay, system software, all the possible MCQs related to system software, language translators, application software, everything we'll be discussing. Later in the next video lecture also we'll be discussing each and every concept, operating systems. Another video lecture will be discussing Boolean logic. So the syllabus content wise, in each video lecture we'll be covering one particular concept with all possible MCQs, covering also important MCQs from easy to difficult level, that is like UG or PG level questions. Everything will be covered in each video lecture. Okay, so if you like this lecture, please like, share and subscribe to this channel for more videos. as we are discussing each and every concept clearly until the exam date with last minute revisions, with including easy to difficult level questions, and all possible MCQs will be discussed. So subscribe to the channel for more videos. Next coming videos, like every alternate day there will be a video released in this channel, so please follow for all the possible MCQs also being discussed with the concept also. The concept will be discussed from the options itself. From the given options we can cover more of the concept also. So subscribe to the channel. Thank you, learners.